Hi, I'm Adam Smith from the marketing team here at LightPoint, and this is my 3 for 3. How is Wi-Fi 7 different from Wi-Fi 6 or Wi-Fi 6E? Wi-Fi 6 introduced a huge change in the way that Wi-Fi works, really targeting making Wi-Fi more efficient. It was the biggest structural change made to Wi-Fi since the introduction of OFDM technology in the standard 20 years ago. What made Wi-Fi 6 more efficient was the addition of multi-user technology. So previous generations were really only a single user at a time, and moving to this multi-user OFDMA effectively breaks compatibility with previous generations of Wi-Fi. And backwards compatibility has been one of the hallmarks of the technology that has really aided in its adoption. But because Wi-Fi 6 was such a major change, it's created some practical deployment challenges. If we look at Wi-Fi 7, the technology really has three major changes. The first is it's got blazing fast speeds. So it's targeting roughly 5 times faster than the top end of Wi-Fi 6 or Wi-Fi 6E. The Wi-Fi 7 spec has actually outlined a path to nearly 50 gigabits per second of wireless speed. The next change in Wi-Fi 7 is lower latency. So it's targeting to get into single digits of milliseconds of latency. And this is going to be a key enabler for time-sensitive networks, for example, in IoT, as well as latency-sensitive applications like VR and AR. Finally, the third major change is basically just adding flexibility to make it simpler to deploy. It's one thing if you can rip out an existing network and replace all the devices in that, but we really need in Wi-Fi to coexist with legacy technologies, and Wi-Fi 7 has added some tools to make that simpler. Tell me something about Wi-Fi 7 that many people don't know. Something that people may not know is that the features of Wi-Fi 6 can actually be pretty tough to deploy and coexist with other legacy Wi-Fi technologies. Additionally, a dirty little secret in the industry is that many existing enterprise deployments of Wi-Fi only use 20 megahertz channels, even though we've been talking about 160 megahertz channels for over 10 years. There just hasn't been enough clean spectrum available to easily deploy the latest Wi-Fi features. And roughly half of the 5 gigahertz spectrum operates under special rules, so many access points choose to avoid these channels. To simplify deployments, the industry has chosen to standardize on narrower channels. But in Wi-Fi 7, there's some features that are now available that make it more flexible to deploy, including how to make it practical to deploy wider channels. Some of the cool features of Wi-Fi 7 are called preamble puncturing and multi-link operation, which you'll hear people call MLO. So preamble puncturing sounds a lot more violent than it actually is. What this really is, it's a feature that allows a Wi-Fi 7 access point to overlay a wide channel on top of the spectrum where a legacy AP is broadcasting. For example, a Wi-Fi 7 access point can detect a legacy 20 megahertz channel and remove or puncture it out just the 20 megahertz that's occupied by the legacy AP. For a 160 megahertz channel, this effectively would give you 140 megahertz of usable spectrum, and at the same time peacefully coexist with the legacy AP. Multi-link operation, or MLO, is another feature that helps with these wider channel deployments. In Wi-Fi 7, on paper, some of the blazing fast speed is coming from the addition of 320 megahertz channels. But we're in this practical issue where there's just no real estate to put 320 megahertz channels. There's a few in the 6 gigahertz band, but there's none in the 5 gigahertz band. MLO actually allows the device to use different portions of spectrum simultaneously to effectively get to a wider channel. So for example, you could use 80 megahertz from the 5 gig band and 160 megahertz from the 6 gig band. And in the end, it's as if you had a single 240 megahertz channel. So with Wi-Fi 7, with preamble puncturing and multi-link operation, there are now multiple tools in the toolbox that allow a practical deployment of wider channels that allows you to achieve these higher speeds. From a test point of view, what is important to know about Wi-Fi 7? For test, I would break this down into two different areas. One is performance, and one is an explosion of test cases that we need to cover. On performance, Wi-Fi 7 has driven significant requirements for the test equipment due to the use of the 320 megahertz channels, as well as more complex modulation techniques. We are now using a modulation technique called 4096 QAM, or QAM. You can think of this as a dartboard with 4,096 points on it. And each point on the dartboard is like a word in the dictionary. If you're trying to send a message between an access point and a client device, you want to make sure you hit the right points in the dictionary. And if you hit the wrong point, the sentence is going to get garbled up. So accurately modulating these signals is very important. And in test, we use a metric called error vector magnitude, or EVM. And this quantifies multiple performance factors simultaneously. It gives you a number ultimately that tells you how accurate the transmission is. And EVM is basically a three-legged stool where the legs of the stool are linearity, phase noise, and signal-to-noise ratio. And there's always going to be one of these factors that's limiting the EVM. So for example, if you're limited by phase noise, there's no amount of improvement in the linearity or the signal-to-noise ratio that is going to improve the overall modulation performance of the system. It's very important to keep that stool in balance. In Wi-Fi 7, both the wider channels and the 4096 QAM stress all three of these parameters simultaneously. So accurately making Wi-Fi 7 measurements means you need to perfectly balance this three-legged stool. And you need to make sure that your test equipment is actually measuring the device rather than its own performance. Circling back to the flexibility of Wi-Fi 7, in test we need to consider the sheer number of new test cases, particularly if you are trying to comprehensively characterize the performance of your device. We already talked about new channel bandwidths and modulation rates, but additionally, preamble puncturing, multi-link operation, as well as some additional deployment flexibility features require extensive characterization. There are some issues that will only be seen in the device when it's operated in these modes, and they could be due to a wide variety of things. I mean, things such as power supply coupling, thermal heating issues, maybe some other non-linearities in the power amplifier or the filtering, and these are going to be somewhat situationally dependent. For testing Wi-Fi 7, we need to make sure to comprehensively cover both the stringent performance requirements as well as the multitude of modes introduced in the standard. Wi-Fi 7 is both a natural extension to the foundation of Wi-Fi 6, enabling much simpler deployments, as well as a technology that's stressing the limits of physics to deliver blistering fast speed. At LitePoint, we're going to keep pioneering innovative solutions for helping you get your designs to market and ensure that they worked the way that they were intended to. Thanks for watching today's 3 for 3, and see you next time.